welcome back. In this video, we'll be looking at some very important logarithm rules or laws of logs. So I will be proving them for you to start with, and then we'll use them in action next. So let's get started. Alright, so we are calling this constant b log of base a x and this constant c log of a y. So how can we rearrange it so that we'll have x and y? That means that, what does that means that a raised to the power of b is x, right? So let's rewrite both of them, and using the same notation, a raised to what? A raised to the value of c equals to y, because y and x are the result of exponentiation. All right, so just we had to multiply x and y together. We would have to multiply the left side of the equations together as well, right? So on the left, when a to the power of b is multiplied by a raised to the power of c, what do we do with the multiplication? We use index laws and add b and c together, right? So then if we have this value here and this line of this equation here, we take log of both sides. Let's say base a will cancel, right? So we left with b plus c equals to this log here. What was b? It was log of ax, and what was c? It was log of a base a y. So we can put them back here. I'm just rewriting b and c as their original definitions here. And so we get our very first logarithm law. So log of base a xy, when there is multiplication here, that you can you can like expand the bracket there and write a plus sign between these two logs. You can go from right to left if you have to simplify this expression here. On the right side of the equation, you can write this that way, or sometimes you may have to go and expand this and write it like so. It very much depends on what the question wants you to do. So these two are equivalent. So let's explore the next law here. I'm going to draw a line here, and that same x and y that I showed you there, now instead of multiplying them, we're going to divide one by the other and see what happens. So x divided by y means that a raised to the power of b on top of the fraction and a raised to the power of c on the bottom of the fraction. So that means subtracting the powers from each other. So now that we got this expression here, we're going to take log of both sides now. So taking log of the very left and the very right means this. We're taking log of base a of both sides. So those log a and base a and a cancel away there. We're left with b minus c on the right side and this expression here. But what was b and what was c? Let's look back at what we started there. B, if we rewrite those equations right here, this was b and this is c. So this is our second law of logarithm. If you have a log and you have x divided by y, you can write it as a subtraction, or vice versa. If you have two different logs and the base is the same, notice the base has to be the same for this rule to work. Okay, it won't work if the base of logs is different. Now here comes the fancy part here, power rule. So you know that x to the power of n can be written, I'm just rewriting inside the log here, rewriting x n times. I don't know, it could be n could be 3, 4, 5, it could be just 2, and I wouldn't need to have so many n's, x multiplications, but I'm just saying, let's say that n is bigger than 2 in this case, so we will have more terms here. So what does that mean? We're going to just use the rule above it. Look, we have this multiplication law. We said when we have x and y here times each other, we can rewrite it as these logs here. two logs. So we will have n logs. By this product rule above it, we have n lots of those logs, right? Plus sign with plus sign between them. That's coming from this law here above it. Notice these times here, I turned these times, I expanded those. All right. So there. Now we can, because all of these x's will be the same. After all, this base x is the same x. So I'll just give in the indices to count them. They are the same numbers, so I can write them as just n times log of ax. So notice I told you I will prove this rule for you. When you have a power here, this power can simply come and sit at the front. We're not differentiating or anything. We're just rewriting the same expression there. These two expressions, n log a x is the same as that. All right. So there's the proof there for you. Proof is in the pudding, as they say. So now the reciprocal rule is just using an index that's a negative number. So just using our power rule here, you could think this is just power that's coming to the front. So taking log of both sides, there was a minus one here that's coming at the front. So it's just the same thing written again. So sometimes when you see something in a denominator of the log, it's the bit that's got a minus sign on. So it's just like having this having a one for x here. All right, that one for x, and we just taking log of that. That means that you're going to get negative of log. Log of one is actually zero. We have 0 minus log of base a y. All right, so think of it like that. And like here, like it's already there, you see. We already had looked at it before anyway, but there is a explicit proof for you there. So if you have some number, some index that's not minus 1, it might be some other number, you can write it like so, like this line here. So these red lines are the things you need to put in your notebooks and remember them for the rest of your life. Okay, so I think there is a change of base formula as well, which may go back and say I've written just what's in the top left corner here again at the in this corner here. So this is just the same x and y that was there. But now that I have a raised to the power of b is x, I can do some fancy manipulations here. I can take the root and like say I want to get a on this side of the equation, so like taking the b root here. So I'm multiplying both indices by 1 over b here, so the b cancels away there. So now if I take log of base a, what do I get? And do this say substitute this, actually sorry, I can substitute this a into that expression for y. I will get this expression here. I replace this a into that expression there. So I've got now multiplying the indices with each other. C goes above b. Now taking log of both sides, what I end up with, I'm using this load that brings the power down, let's say the power rule here, this index from x, I'm taking log of base x, so that the c over b came down at the front, these two cancel away, and I've got log xy. So what was c to start with? It was those two. Let's write them down like so. So every time you have log of base x, y, you can rewrite it as a different log altogether. Now, we will explore natural logarithms in later chapters, but e to the power of x, if that gives you y, the opposite of, or rather log of base e can be written as uh, ln. Okay, So if you have, that's why I said if you have at the beginning of the lesson, if you remember, we had some question 1.5 raised to the power of x equals to 2. And I said instead of writing log of base 1.052, I said you can also rewrite this as ln of 2 divided by ln of 1.05. I was using this rule here, this change of base formula here, where e is, this ln is just saying log of base e here and log of base e here. I'm using base e rather than this base of 1.05, because on your calculator ln comes is has its dedicated button anyway. If you look at any calculator, next to the bottom or on the bottom e to the power of x, you also have ln button as well. Anyway, so let's use these rules to solve some problems. If you want to take a picture and copy these down, this is the time to do it. All right. So I hope you've made note of this. Let's use them in action. So change of base rule, once again, we went through it and is just the same thing. So I always ask my students to go through this exercise and make sure you know which one's the right rule and which one's the wrong rule. Some of them are correct and some of them are incorrect. Pause the video, cross off the ones that are wrong, you think they're wrong, and tick the ones that are correct. So I hope by now you've paused the video, you've had a go at these, so you should have some answers like so. These are the wrong ones, and um, and they are just common mistakes a lot of students make. Let's see. A lot of students, when they have minus here, they think, oh, I can turn minus there into division. No, that's not what we said. We didn't say if you have plus here, you can turn it into multiplication. Only if you have multiplication here, if you have multiplication, you can turn that and expand the logs here, write it as two separate logs, and then add plus sign there. So there you go. These are the wrong ones, those are the correct ones. All right. So I hope you like that. So just using these four rules here, these rules are there for you just to help you out. It won't be there in your exams, so remember these for yourselves. Okay, here we are going to combine these two logs together. That means, what do we do with 6 and 7? We can multiply and write it as one single log. Log of base 3, 42. And the next one, pause the video, have a go at it yourself. Alright, I hope you've had a go at this. You simply going to divide 15 by 3 and write it as a single log here as such. So here you can use the power rule, bring the 2 for the power of 3 here. Use that power rule in reverse, bring this 3 for the power of 2 there. So we'll have log of base 5. What's 3 square? 9. And what's 2 raised to the power of 3 is 8. And then now you can multiply 8 and 9 with each other. You end up with 872. All right, so there you can write it like so. That's simplified. Finally, go through this slowly and carefully. Pause the video if you wish. There you go. So I'm going to show you the answer. You can bring the 4 and raise half to the power of 4. It will be 116. Then you can now divide, because of the minus sign between the logs, you can divide 3 by 16. That means turn the 16 upside and multiply it by 3. Now this, you can use it in many different ways. You could have just taken -4 and put it here and put a plus sign. If you take the minus with a 4, that would have also worked. That would have given you plus log of, what is half raised to the power of -4? It would be 2 raised to the power of 4, which is 16, and that would also lead to the same result, because you would multiply 3 by 16 and the base here is 10. So let's look at some other work. Yep, so here, pause the video, have a go at these. You're gonna expand these logs. The opposite applies. So we wanna write them in terms of separate log of ax, log of ay, and log of az. So you would end up with this expression here. And if you want to pause the video, have a go at the next three, go and do it now. Alright, so this is the answer here. We are rewriting as something as with just the logarithm rules that we learned. First, you can rewrite the next one as y to the power of a half and use the logarithm rules. Anything in the denominator, we will give a negative sign outside of the log, and anything in the numerator will have a positive sign outside of the log. So it will look like so. That will be a 1. Alright, so now we are looking into solving equations one more time. Now you can say this 2, I can divide both, if it's outside of log, we can divide both sides by 2, and then we'll have this expression here. That's one way. If I divide by both sides by 2, I would get 4 here. Then to get rid of log of base 2, I would raise both sides to the power of 2, so I would have 2 raised to the power of 4, x will be 16. So if we move the 2 as the index of x, now we would have to use base 2 of both sides to get rid of the log. 2 to the power of 8 is number 256. Now we would have to square root both sides and we would have a minus. But why do we ignore the negative 16? Think about it. Can I give a 16 to log? A positive 16 works, but a negative 16 doesn't work. Error. So we ignore the negative. It's important that you actually eliminate and not give a negative 16 to examiner. So solving this equation for x, you could use 2 and remove it there, and then combine these logs because they are both base 10. We could write it as 1 log, log of base 10 of 4 lots of x squared equals to 2. Then we use base 10 for uh, removing the log, and we would write it as 10 to the power of 2, which is 100. So 4x squared is 100, therefore we divide by 4 and we take a square root. And because I have an x here, I know that x has to be positive. It cannot be negative. So I'm not gonna write a minus sign. I did take a square root of 25, but I'm ignoring minus 5. I'm having it written as 2. So that's a nice way of writing it. It's the same way of writing it. Actually, it's no difference here. So this next question is appearing next to it, part B. So here we can combine these two logs here and write them as log of base 3. Write it as one fraction where x plus 11 must be on the top, and this minus tells me everything in this log needs to go in the denominator. And now I can get rid of this log by using base 3. So x plus 11 over x minus 5. I guess I don't need a bracket there because I'm going to say 3 squared there is going to be a 9. And then I cross both sides by 9 by x minus 5. Multiply both sides by x minus 5. I will have 9x minus 45, and this is a simple linear equation. I subtract x from both sides and add 45 to both sides. So I will end up with 8x equals to 56, and dividing both sides by 8 gives me 7. Okay, and yes, it's a positive number, so that's great. So there is same working out, you end up with 7. So I hope you've enjoyed this, and I will see you in the next video.